start? Or shall I wait? Okay, good morning all of you. Now, this is going to be very short than what we had talked yesterday. About 20 minutes, I will try to finish this up. Now, we are going to talk about defibrillation. So, some of the important things which as postgraduates all of you should know, and in your daily practice what you should be doing. What is defibrillation? All of us know it's a non-synchronized shock which is given during a cardiac cycle. And what does it do? It helps to depolarize all the muscles of the cells so that they can contract synchronously. Right? When the children don't listen, you give them a slap and they start talking synchronously, all of them. It's like giving a slap to the heart. Some people follow it up by a precordial thumb. That is also advisable, that before you start with defibrillation, a precordial thumb occasionally would be helpful, although it is not in the guidelines anymore. Now what happens is that the electrical current goes always from the negative side to the positive side. That's how the electrons will get transferred out. And it traverses through the entire myocardium, therefore depolarizing all the cells together so that the next contractions, they all talk in a single or all contract rhythmically in the same manner. Now there are two types of defibrillations. One of them is AC defibrillation, the other is DC defibrillation. Have any one of you used AC defibrillation or have an idea what is AC defibrillation? This was the first type of current which was used. That's how defibrillation came into practice, and it was used by Beck in open cardiac surgery. So what you do in AC defibrillation is you use the sockets which are available here. You don't have to carry any instrument with you. The same power socket gives you the power source, electrical source, and that is what is used for AC defibrillation. But the problem is, the volts which it is providing is not enough. We need a step up voltage stabilizer. It needs to step up the volts. The frequency of current is about 50 to 60, and it is the time duration during which you administer AC current can be 0.25 to 1 second, right? But if the voltage is about more than 1000 volts, then the time's duration has to be limited, and it has to come down to almost 100 to 150 milliseconds. Current strength in amperes which is used is about 6 amps. So these are certain standards which the AC defibrillators were being used. It's no more in use, but is again coming into practice. Some of the papers have come. The disadvantage was it would not produce a stable current. Now when we talk about a particular voltage, you look at DC, you produce a stable voltage throughout whenever you put on the DC current, right? It's a stable voltage. But when you talk about AC, it is an undulating waveform. So it doesn't give you a stable current all throughout that phase. So the problem was when it was not giving us a stable current, then after defibrillation, the current can induce fibrillation again. So that was the main issue which these defibrillators were producing. But if this voltage was shortened to an extent to synchronize for a small duration, so that the next part of the current when it is undulating is avoided, then possibly it could work. And that is what the principle they are bringing in the current research. Anyway, because of these disadvantages, the myocardial damage which was induced, this was discontinued. Now DC defibrillation was introduced by Lone in 1962, and it uses a capacitor. It's a physical terminology, but all of you must know because all your laptop chargers, everything is a capacitor, right? So capacitor is nothing but it has the ability to store electrical energy. right? So you can say, what's the difference between battery and a capacitor? It should be the same, correct? But battery, what happens is, it will slowly give away a certain amount of charge. It will continuously give till it is discharged. Capacitor has the ability to suddenly offload all the charge in no time. The moment you press the button, all the charge in it can be offloaded. But battery cannot do that. It will continue to store and it will give you a stable current for a longer period of time. So this is the difference between capacitor and a battery. Now, just to know about these capacitors, because that's the heart of the defibrillator. If you don't understand what is a capacitor, you will never be able to troubleshoot your defibrillators. Okay? So you must know about something, some small physics about this. It has two conducting plates. Conducting plate means both of them have electrostatic charges, but they are electrostatically neutral. That means same number of protons, same number of electrons are there, but they are not in contact. They are separated by an insulation called a dielectric. So the principles of working is that you need to have a DC current to charge these capacitors. So you need to charge the capacitors so that they can store the energy. The storage of the charge is equal to the voltage applied, and storage of the charge or the capacitance is termed in farads. That's the unit for capacitance. So the developed voltage will give you the supply voltage. So whatever voltage has been developed in the capacitor, 1000, 2000 volts, that is what will be the supply, that will be what it will be storing. So whatever voltage you supply to the capacitor, that voltage it will store. Discharge of the energy, it requires a conductive switch and a conductive path. It will store, but somewhere you have to bring the plates together so that it can discharge. Okay? So that's how it has to work. I will tell you how it does. So let's look at this, how it works. So this is two plates, right? Two conductive material. They are separated by a dielectric or an insulation. Now I told them that both of them are conducting materials, so they are electrostatically neutral. Same number of protons, same number of electrons. Okay. Now when I connect it to a battery, which has a particular voltage, what will happen? All the electrons from this plate will go towards the positive side of the battery. Right? So the electrons from here are going towards the positive side of the battery, and these electrons will anyway move towards this positive part of the dielectric. Right? So this is what will happen. It will keep happening. So if this is allowed to keep, is going to happen, then one side of the plate is going to get much larger number of electrons. So there will be a number of larger electrons which will be built up, and there will be a potential difference between the two plates. So this will be only positively charged and this will only be negatively charged. Is it alright? Right? So this becomes, there is a potential difference which has established, but they are not able to move across, although there is a potential difference. How much voltage it is going to store depends upon what is your supply or the voltage given by this battery. So next is that once this is established, when you have a potential difference, it will form an electrical field. So when an electrical field is formed, then if you connect a conducting path with a switch, right? Now if you connect a conducting path with a switch, which you have in the defibrillators, as soon as you put on the switch, there will be a electrical flow, and this bulb which I have lighted here will glow. Right? So this is how the capacitor works. Simple. Now DC defibrillators, you know, have two forms of waveforms. Normally it is known as a monophasic waveform or a biphasic waveform. Now monophasic also has two types. One is a truncated exponential, the other is a damped sinusoidal. Biphasic waveforms can be rectilinear or a truncated exponential. These are terminologies which are used how the current flows, right? In what capacity it flows. So just to tell you what is monophasic. So this is volts, this is time, and I told you the current flows from the negative side to the positive side. So this is the negative side, it will flow to the positive side here. So this is your monophasic. One peak will come. So one peak intensity comes, during which the defibrillator has to overcome all the impedance and the resistance of the body to deliver the shock inside the thorax cavity to the myocardium. So this peak current is extremely important, how much you produce. Right? So initially the monophasic defibrillators which we were using, they needed a peak current or almost 360 joules, right, to produce this peak current so that it could overcome all the impedance and the resistance of the body and defibrillate the heart. So the pulse width was about 10 milliseconds. Now, what is this monophasic damped sinusoidal and how does it do? The current intensity here gradually comes down to zero. So it is taking some time, and over about 10 milliseconds or 8 milliseconds just touches the baseline. It's a gradual fall. It's not a sudden fall. Like your volume control and pressure control. Right? What happens in volume control? Same thing. It goes up slowly and then it slowly empties. Pressure control, you get an immediate rise, sustained, and then it suddenly falls to zero. Almost the same. Monophasic truncated exponential waveform is just like a pressure control ventilation waveform, right? So that is how it happens. It rises suddenly, it sustains that current, and then suddenly falls to zero. But it is given for a larger period of time because the peak current here is much less. Here the peak current is much higher, so you have to give it only for a small period of time. But when your peak current is less, you need to give it some time so that it can traverse and overcome all the resistance and impedance to defibrillate the heart. So this is the difference between the truncated exponential waveforms and damped sinusoidal waveforms. What is biphasic? This is a common question asked, right? The electrodes are the same, right? And what does it do? Just watch these electrodes. The current comes from here and then the current comes from here. So there is an onward journey and there is a return journey of the current. How does the return journey occur? How does the return journey occur? The current will only flow from negative to positive. So when it has gone to the positive side, how does it come back? Anyone? If you watch the diagram, you will know it. Just watch it clearly. Watch the colors change. What happened? The defibrillator has been given the capacity to change the polarity of the electrodes. Okay. So as soon as the current reaches the positive, the defibrillator changes it to negative and the other one to the positive. So the current flows back. Right? So that is why it's got one phase here and then another phase here. So what it does is it gives you enough time, it gives you less amount of energy to be introduced, and it will defibrillate the heart in a much lesser amount of current which will be required. So that is what is called a burping response which you want to do. Again, same thing with your biphasic. It has got two type of waveforms. It can be truncated exponential or it can be rectilinear one. But whatever studies have come, they say nowadays the rectilinear is much better than the truncated waveform. Because the number of joules required with rectilinear is only about 120. You don't have to go up to 150 joules. So what are the advantages of our monophasic versus biphasic? Lesser power is required with biphasic, so you have less trauma and less battery consumption. You don't need to have larger batteries to store that much of energy. More effective defibrillation at low energy level. So first success shock rate is much higher with biphasic. It is almost 90% as compared to 60% with monophasic. Complications, lesser myocardial damage and pure incidence of birth. Now all of us, whenever we do our anesthetic practice, what do? We check our machines. How many of you check your defibrillators? How many of you have a defibrillator in the OT? Raise your hands. All of you have. How many of you check your defibrillator in the morning? Raise your hands. None of you. How do you know it's working when you need it? See, this is one of the problems which you must identify. It's a life-saving equipment. It's a life-saving equipment. And if someone knows or someone leaks the information that patient had a shockable rhythm and the defibrillator was not working, every one of us would be in a problem. Because it compounds to negligence. Right? So it should not happen. Every day you must check your defibrillators also. That's precisely I am taking this lecture, not for anything else. The message is here, which I want to convey to all of you. Right? There is a daily low energy test which is described by company, and there is a weekly defibrillator internal discharge test which has been devised by us. Reason is, we used to do the daily test. Daily test was charge it to 30 joules only and discharge without taking out the paddles. So when we were using daily test every day, when we wanted to use it for a patient, the battery or the capacitor didn't charge up to 200 joules. We could not shock the patient. Because every day we were charging only to 30 joules. And we were thinking it is working correctly, despite checking it every day. So these are the issues which you can have. And imagine if one of us is there, or one of your relatives is there, and it is a VF, and the defibrillator doesn't give the energy. What face or what will we feel for the entire life? Today is one patient, next day it will be us. We are not going to escape that terminal moment. All of us might face a defibrillation anytime. Right? So take things very seriously when we talk about these life-saving equipment. Now, what happened was, we were supplied by 845 of Zoll M, a very reputed company. Zoll M series of defibrillators. And 8 of the 45, so incidence is almost 25%. 8 of the 45 defibrillators were unable to charge above 100 joules. This is the most standard. Zoll is supposed to be the first introducers of defibrillators. And this series, we found 8 of them which were not functioning adequately. So that's why we published this in IJA specifically. Now what is this daily low energy test which you should do? So there is an AC power supply, you connect it to the AC power supply, it will grow in green. The moment you cut off the AC power supply, it should work on battery. Battery should be working properly because it needs a change every 6 months. If you have to carry your defibrillator to another source where there is no AC supply, your battery should give the shock. If you only put it on to AC supply and do the check, then you can only shock with the AC socket on. Right? You cannot use the battery. So what if it is to be used at a place where there is no AC supply? Your battery is not working, you will not be able to shock. So all the test is done by switching off the AC supply, and then you have to do this. So put the defibrillator on battery mode. Next is select the defibrillator mode. So there is a button here which says press to select. This is an AED button. You have to go to manual mode to go to defibrillator mode. So all of you should know that. Right? So what do? Just look at this video. I'm just switching it on. The defibrillator is switched on. Right? I press this AED mode here which says manual. It asks me to confirm whether I want to go to manual mode. I said confirm. Now it has come to defibrillator mode. 120 joules. right? So once you are at defibrillator mode, you select 30 joules. Defibrillator paddles are kept apart where they are. Then you select the lead. It is saying ECG lead 1 because the ECG leads are connected to it. Okay? So you need to select paddle mode. ECG 3, now it comes to the paddle mode. Then only it will deliver current. Still, there is a flaw. It may not deliver the current. The reason is this power cable has to be attached to the defibrillator pad. If you don't attach this, the power will not come to the paddles. Okay, it's very easy to say defibrillate, but this is what you need to do every day to know how to give the shock. So once you have connected this universal cable to the paddles, which is generally not kept connected, right? Then select the energy mode to 30. Charge it up, let it go to 30, and it will give you a continuous beep, audio visual beep, that it is ready. Next, what you will do is you go and select both the buttons and then discharge. It says test is okay, right? So this is what you do on daily basis, every day, so that you know how to put it on defibrillator mode, you know how to charge it, and you know that the universal cable has to be connected. These 3 steps, if they are missed, any one of them, you will not be able to defibrillate the patient. So please get familiar with your defibrillators. They are just not there to as a thing to be kept. Now after you have done this, now you do a weekly test, and this is very important because we don't recommend, or the company doesn't recommend, to give 200 joules through the machine because that much of energy can spoil the internal parts of the defibrillator. So every day you cannot do it. We do a low energy test every day, just 30 joules. This is not recommended by or not written by the company. Now what we said is, the capacitor has the ability to store the charge, right? So we have to test whether it can charge up to 200 and whether it can sustain that 200 joules. So what are the components? Again, you go to select 200 joules, and then for 50 seconds do not deliver the shock. It will continuously give you an alarm. And after 50 seconds, if it is able to hold the charge of 200 joules for 50 seconds, then your capacitor is working well. You don't have to discharge it by pressing the buttons. So the last step can be omitted. Second last step, charging to 30. Instead of 30, you charge it to 200 and just leave it. By clock, wait for 50 seconds. If it holds the charge for 50 seconds, your defibrillator is charging well to 200 and it will discharge. You only have to press the buttons to discharge. So just watch this video how we do it. It's on paddle modes. I'll go to the previous one with the whole thing, which will be better for you to look at it. Yeah, just watch this video properly. Now what are we doing here? Put it on. The defibrillator comes on, right? This one is for 30 joules. Wait. Yeah. Okay. So what do we do here? We select 200 joules. It's on paddle mode. Universal is kept here. It is charging to 200 joules and it is ready. Just leave it like this. Keep watching the time. It is still saying ready. I have switched off the. This noise will keep coming. The alarm will keep coming. Just keep on. Just don't do anything for it. Watch for 50 seconds. It still says 200 joules ready. So we'll just allow that 50 seconds to elapse. See, now it says
Now you get that kind of a interrupted beat, right? Now it is gone. The ready, what was seeing ready, it is gone, it says select. So that the defibrillator is automatically discharged the amount of current which it was holding. You have not pressed the button. Right? So what it does is it doesn't deliver that charge to the machine components. It avoids the damage. At the same time, we know that it is charged to 200 joules and it is going to sustain that energy. I only need to discharge it by myself. Or the machine is going to discharge it by itself. That's the weekly test which you must do. Okay. Am I clear? Okay. Now, once you have checked your defibrillator, then you come to the steps of defibrillation. It is very easy now because you already know half the things what you need to do with the defibrillator. You only have to put the pads and shock. So you start your CPR till the defibrillator is arranged. Turn on the power to defib, select the defib mode, select the paddles, don't leave it on leads. Ensure paddles are connected to the defibrillator, applied electrode jelly on paddles, place them on anterolateral position. It doesn't matter where you put the apex or the sternum, it only has to go from left to right. Either it will go from here to here or from here to here, it doesn't matter. Right? So it doesn't matter where you place the paddles, which one you place where. Identify that there is a shockable rhythm. It should be a shockable rhythm. Select the charge level to 120 joules. Press charge, confirm the selected energy. Instruct all personnel to stay clear. Press shock button on both paddles to deliver the shock. After delivering the shock, resume CPR for 2 minutes and assess the rhythm. If second shock is needed, select 200 joules now and deliver it in a similar fashion. What's the difference between defibrillation and cardioversion? Just go through this slide. Right? Defibrillation is an emergency procedure. You give an unsynchronized shock. Energy levels are high, 120 to 200 joules. But here, cardioversion, it is much less. It is no delay immediate. In cardioversion, you can have some delay because it is an elective case. You don't need anticoagulation for defibrillation. Myocardial damage is much less, and defibrillation is only given for VTAC and VFib, not for other rhythms. For other rhythms, most of the arrhythmias except VT and VF, we use cardioversion. This is a patient who had been delivered multiple shock outside the hospital when he came to JIPMA. Look at the burns they have created because they have not applied a jelly properly. Look how many shocks. You can just count the number of shocks and this. Ultimately, we were able to save him. But look at the number of shocks when he came to us in the ICU. So just to summarize, remember there's a component called AC defibrillation. It is coming up now. Monophasic and biphasic, the joules are different. Main component is your capacitor. It stores energy in form of electrical field. Defibrillator checklist, low energy every day and an internal discharge test of 200 joules every week. You should know what are the steps to perform defibrillation and just know what is the difference between cardioversion and defibrillation. Thank you very much.